Look up, if you will. Take a moment to truly see what's there. On most days, through clouds or clear skies, you'll see it. A brilliant orb dominating the sky. A constant presence, a familiar friend. We call it the sun, a simple name for something so complex and vital. It rises faithfully each morning. It sets in a blaze of glory each evening. It warms our faces with its gentle touch, and we rarely stop to truly consider what it truly is, its profound impact, its silent power. We take it for granted, like the air we breathe. The sun is not just a light bulb hanging in the sky, it's far more significant than that. It's not just a source of light, it's the engine of our world, the silent benefactor sustaining all life, the very heartbeat of our planet. Every meal we consume, every breath we take, every thought that sparks within us is powered in some way, directly or indirectly, by that distant radiant star. It's the ultimate source of our energy. Without the sun's constant embrace, Earth would quickly transform into a frozen, desolate, lifeless rock, a barren wasteland drifting through the cosmos. Its presence dictates the very rhythm of our lives, the tempo of our days. From the most mundane daily routines to the grand, sweeping changes of the seasons. It's the conductor of our planetary orchestra. Ancient civilizations, in their wisdom, built magnificent monuments to meticulously track its celestial journey. And even today, farmers still plant their crops according to its ancient, unwavering schedule. The sun's immense energy is what drives our planet's weather patterns, churns the vast oceans, creating currents that distribute heat around the globe, and, most importantly, fuels the miracle of photosynthesis, the very foundation upon which the entire food chain is built. It holds our entire solar system together with its immense gravitational pull, keeping Earth safely nestled in a life-sustaining orbit, a delicate dance of gravity and energy. We are, quite literally, all living in the radiant light of a star, bathed in its warmth and sustained by its power. So, let's embark on a journey together, a voyage into the very heart of this celestial furnace, this powerhouse of energy. We'll carefully peel back its mysterious layers, one by one, strive to understand its incredibly fiery mechanics, the nuclear fusion that rages within, and follow the almost unbelievable voyage its energy undertakes, traveling millions of miles to finally reach us. By truly understanding the sun, its power, its structure, its influence, we inevitably understand more about the vast universe that surrounds us, and ultimately about ourselves and our place within it. This is a story of immense pressures, forces beyond our everyday comprehension, unimaginable temperatures that would vaporize anything we know, and a process so relentlessly powerful that it has burned with unwavering intensity for billions upon billions of years. This, in essence, is the incredible story of our star, the sun. The sun, our life-giving star, a source of warmth and light. But have you ever stopped to wonder, what is this colossal ball of fire actually made of? What are the ingredients that fuel this celestial furnace? It's not wood, it's not coal, and it's definitely not gas like we burn on Earth. The sun is made of something far simpler, yet far more powerful. The sun is overwhelmingly hydrogen, making up about 74% of its total mass. Next comes helium, which constitutes about 24%. So these two elements alone, hydrogen and helium, make up a staggering 98% of the sun's composition. The remaining 2%? That's where things get interesting. It's a cosmic soup of heavier elements, including elements like oxygen and carbon. We also find neon and even iron. These are just traces, remnants from ancient stars that lived and died long before our sun was even born. Now, imagine the sun not as a solid object, but as a gigantic swirling ball of plasma. It's not a solid liquid or even a gas in the way we typically think of them. The temperatures and pressures within the sun are so extreme, so incredibly intense, that atoms are stripped of their electrons. This process creates a superheated, electrically charged state of matter known as plasma. This plasma, in turn, is bound together by the sun's immense gravity, a force so strong it holds everything in check. This creates the perfect conditions for the magic that happens at its core. And this seemingly simple mix of hydrogen and helium is the key to unlocking the sun's incredible power. The universe, in its infinite wisdom, built its most powerful engines from its most basic building blocks. All it needed was an abundance of hydrogen, the relentless pull of gravity, and the vast expanse of time. This cosmic recipe ignites a process so powerful, so transformative, that it can shine across an entire solar system, and ultimately sustain life itself. Now let's journey to the very heart of our solar system, the sun's core. This is where the magic happens, the engine room of our star. Here, temperatures soar to an unimaginable 15 million degrees Celsius. It's a heat unlike anything we can experience on Earth, a sea of superheated plasma. And the pressures are even more mind-boggling, exceeding 250 billion times Earth's atmospheric pressure. Imagine the crushing force at those depths. It is under these extreme conditions that nuclear fusion happens, the sun's true engine, the source of all its radiant energy. It's a process that has been ongoing for billions of years. Hydrogen nuclei, protons, the most abundant element in the universe, are slammed together with such incredible force, accelerated to tremendous speeds, that they fuse together, overcoming their natural repulsion to form helium. This multi-stage process, called the proton-proton chain, is a complex dance of subatomic particles, and it releases a tremendous amount of energy in the process. When 4 hydrogen nuclei ultimately fuse together, the resulting helium atom has slightly less mass than the 4 original hydrogen atoms combined. That seemingly insignificant missing mass is converted into pure, raw energy, a phenomenon perfectly described by Einstein's famous equation E = mc2. Every single second, the sun converts an astounding 600 million tons of hydrogen into approximately 596 million tons of helium. So, what happens to the missing 4 million tons? It becomes pure energy, released into space, radiating outwards and ultimately powering our world, sustaining life as we know it. In effect, the sun loses 4 million tons of mass every second, a continuous and colossal transformation, all to keep its lights on, to bathe our solar system in its life-giving light. This incredible process is the secret to the sun's remarkable longevity and immense power. It's not simply burning fuel like a fire on Earth. It's fundamentally transforming matter into energy, a far more potent and efficient process. This is far more efficient than any chemical reaction we can achieve or observe on Earth. And that's the sheer brilliance of our star, a cosmic powerhouse fueled by the magic of nuclear fusion. The energy born in the sun's core doesn't reach the surface instantly. A photon created in fusion begins a long, tortuous journey through the dense plasma. It zigzags, colliding and being re-emitted countless times, a random walk that can take up to 1 million years. After this trek through the radiative zone, energy reaches the convective zone, where hot plasma rises and cools, creating massive churning patterns. Finally, the energy reaches the photosphere, the sun's visible surface. The light that escapes here is what we see as sunlight. It's astonishing. A photon's journey from the core to the surface takes longer than all of human history. Only then does it begin its final sprint to Earth. Once a photon escapes the sun's photosphere, its journey is swift. It travels at light speed, over 93 million miles in just 8 minutes and 20 seconds. If the sun vanished, we wouldn't know for over 8 minutes. Sunlight is a message from the past, a snapshot of the sun as it was minutes ago. The sun emits energy across the electromagnetic spectrum: radio waves, infrared, visible light, ultraviolet, X-rays and gamma rays. Earth's atmosphere and magnetic field shield us from most harmful radiation. What gets through is the perfect blend of light and heat. This solar energy powers our climate, drives winds and ocean currents, and sustains ecosystems. Even small changes in the sun's output can shift Earth's climate. We live in a Goldilocks zone where the sun's energy is just right. Solar energy is the foundation of life. At the base of every food chain is photosynthesis, plants, algae, and some bacteria turning sunlight into chemical energy. They use chlorophyll to capture sunlight, convert carbon dioxide and water into sugar, and release oxygen. Animals, including us, depend on this process, directly or indirectly. Every meal is stored solar energy. Sunlight also shapes our biology. It sets our circadian rhythms, triggers vitamin D production, and signals the seasons. Life on Earth is powered and choreographed by the sun. We've even learned to mimic plants with solar panels, converting sunlight into electricity. The sun's influence is woven into every aspect of our civilization. Humanity has studied the sun for millennia, but you can't just stare at it. Early astronomers projected its image to track sunspots, revealing the sun's dynamic nature. Today, massive solar telescopes and advanced optics let us see features as small as a city block, Spectrographs break sunlight into its spectrum, revealing the sun's composition and magnetic fields. To see more, we go to space. Satellites like NASA's Solar Dynamics Observatory and the Parker Solar Probe give us a 24/7 view. The Parker Solar Probe even flies through the sun's outer atmosphere, sampling particles and magnetic fields. These missions help us solve mysteries, like why the sun's corona is so much hotter than its surface. Together, ground and space observatories reveal the sun's secrets. The sun isn't always calm. It has its own weather, driven by powerful magnetic fields. These fields twist and snap, releasing energy as solar flares or massive eruptions called coronal mass ejections. When a CME hits Earth, it can trigger geomagnetic storms. The most beautiful result, auroras, the northern and southern lights. But solar storms can disrupt power grids, satellites, and communications. The Carrington event of 1859 caused telegraph fires. A similar storm today could be catastrophic. That's why forecasting solar weather is vital. The sun's outbursts remind us of its power and our vulnerability. We must watch our star closely. When you look at the sun, you see your own origin story. The elements in your body, carbon, oxygen, iron, were forged in ancient stars. Those stars exploded, scattering their elements, which formed our sun and planets. We are stardust, brought to life by the light of a star. The sun's energy animates us, powering the chemistry of life. This connection, made of stardust, powered by a star, links us to the cosmos. Our sun is ordinary among billions, but for us, it's everything. Studying it teaches us about all stars and the universe itself. The next time you feel the sun's warmth, remember, you are touched by energy that began its journey hundreds of thousands of years ago. We are children of the cosmos, born from stardust and powered by a star.